Is the original title from Fred Astaire and Ginger Rogers' After Hours to The Secret Life of Gyroscopes. Anyway, that was just a joke. Fran McCabe with The Secret Life of Gyroscopes.
Well, I think they had a secret life too, which we hope was pleasant. So I thanks for having us here, and to Dr. Bankston for sponsoring us, and a few other people that gave us some help along the way. So basically we have let's say devices that know how to spin and know how to react to spin and can make vortexes and so forth and so on, and express themselves in a lot of strange ways. Now, we worked with Eric Laithwaite for a while, quite a while, as a matter of fact. He had us make a few devices, and this one, unfortunately, didn't quite work out. But he was into massless motions, or that the opposite spinning gyros would cancel each other's mass out. Now, this device that we made didn't quite prove that out, but that certainly didn't belittle the guy. I actually think he should have, in the Royal Society, he should have stood up a little bit harder, these guys, and said, what is gravity? If it falls and it doesn't fall, move up, look, what do we got here? Then I worked with Professor Manfred Bohm in Stuttgart, Germany, and he wanted us to make a earth-powered motor. Now, we had been sort of guessing at that, so this was going to do a few other things, but then it looked like it could do his job. So we set that up at night and come back in the morning, and it would have moved overnight. Now, it was interesting that he had some of his students figure how much change in the Earth's orbit might happen if all the power that was used, all the wattage that would be used in the world would come off of motors like this. And so we both decided we're going to quit on this. we were a little afraid of how much deviation from orbits, even though we had the reassurance here this morning that it would return to where it started from. Now, I'm going to take a little license here. This device happens to be behind the camera or on the wall, and that's just something that we had worked on with windmills and the power, a motorcycle with air power. And we have one going right now that actually has delivered 100% power from the windmill. So I'm just a little bragging rights there, if you don't mind. Now, some of the writers that we and inputters that we had worked with, Olaf Sundin, who was quite a scientist, and when we were over in Russia delivering a few papers, we got together with him, and he wrote a book called The Hidden Secret of Physics, which is oscillations. And then we sort of got together that gyros make oscillations. Matter of fact, when you power a precession, you can make either oscillations or spirals. We'll get into that in a minute. And Mark Zucker, he mentioned that if once we understand the depth of gyroscopics, we're going to really get into the depths of physics. Glenn Turner's a guy in London, or in England, and he's just a gatherer of all gyroscopic information, so I can let you get on to him if you really want to learn about everybody who's written about gyroscopics. And Claude Swanson, Life Force, I don't know whether he's here, no? Okay. Anyhow, he alluded to he didn't use the word gyroscopics, but he alluded to gyroscopics in his writing his Life Force book, page 360. And I think you could read it that way, that gyroscopic spin is an important part of physics. So hidden secrets, we're going to reveal them here. Seems that it was basically a limited perception to the extent of spin gyro motion physics. It really was mostly focused on stability, thanks to Sperry. And he pretty much stayed, from what I gather from his work, that he pretty much stayed with just stability devices used in aircraft, gyro horizons, so forth and so on. And he didn't get much beyond that. It turns out that Tesla palled around with his son, And Tesla has a lot of input to gyroscopics. All right, so some of the physics, motions, phenomena, gyroscopics, we have arc reversals, where this would actually fall, and then once this wheel gets parallel to it becomes a spoke that ends up with a plane parallel to the spoke, perpendicular to the spoke, sorry. Anyhow, this would fall to that point right about here, and it would reverse itself just like that. I mean, it's so fast you can't even see it happen, or go through the process of reversing. It's violent, as a matter of fact. And that we incorporated a very interesting device that we call anti-gravity. So I'll risk saying those words now. Maybe I'll never repeat them by popular request. Then we have this where we show powered precession. We have a little air-powered motor, 7-pound wheel, spin it about maybe not even 3,000 RPM, and it will lift more weight. But as the powered precession occurs, then this becomes a spiral. And then this device here, we have 2 wheels, one on each side, and my vision is getting a little tough to handle that. So you can't see the wheels too readily, but it's on an arm, like an arm that goes along right there. And then there's some weights, and we have a powered precession motor here. So this we'll elaborate on a little further down the line. So all right, so we have all these adaptations, motoring, oscillation, frequency, self-made spin, self-developed spin by capping a powered spiral. You cap that, and it'll induce spin back into the wheel. And then self-determining power torque adaptations. It's amazing how something can change its torque without having a gearbox, and it knows how to do it, and it senses how much it has to move to actually make this torque stay, make the wheel or the weight stay in the same position, and then precess, and staying in that same position. So all right, we have all these things, and so we do get some opposing questions. I don't know, maybe that's a wrong word, but anyhow, or impolite word. So how can momentum or conservation of momentum be explained for 90-degree precessional motions? 90-degree motions don't have vectors to each other. So precession is a 90-degree motion. So I try to work that out in my head. I don't know how much that really means here, except that I'm trying to say that when you have gyroscopics, you're getting something different than the norm in physics. So that's one of them. So then how can you be maintaining a spin rate while varying the torque and varying the load with different torque without gear shifting mechanism? Then if the spin were to come from storage, why doesn't that deplete the RPMs? So what we see is that we don't see a depletion in RPMs except for the aerodynamic drag and the friction drag is all we can see. And later on we're going to give you an audacious statement, so you can be prepared for that. Be excited about that. Okay, now this is, I don't know, maybe an obtuse question. Are the gyroscopic disparity vectors in work? And so there seem to be some disparities. And from what I read or get from some of Tesla's works, he truly believed that gyroscopics was different. It came from the ether somehow, or space. So all right, just following along these questions would help to learn about these gyroscopics phenomena of motions and power. So right now, what we have, we're going to talk about a little bit further, is we have orbits, and we have translation of orbits, so we have bending of orbit, spin plane, and then we get the 90-degree precession. Then we get into the thing that seems to be what's bypassed, and that is powered precession. So when you have power precession, depending on the arrangement of the geometry, you get spirals or oscillations. And oscillations are a real key, as I was saying about Olaf Sundin. He wrote his book about oscillations as being a hidden secret of physics. Then we have collisions between torsions and receiver converter. And there's some pretty way out type stuff, but I'm hearing from some people here that there's a potential for a belief in that kind of thing happening. And I'll get to that a little bit later also. So now we get into orbits, and what we have, let's just say this is the Earth, and then this would be a particle or a piece of mass or whatever. Now, can this thing really fall from that point to the center of the Earth? I mean, does gravity really work in a straight line? So let's look at it a little bit. So you have, this is moving at x speed, the Earth is spinning. Now, whether they're tuned to each other on the same radial line, radian line, or whatever, you can question that, so I'll just bypass that question. But anyhow, so now we have this particle, say, moving real fast here. Or it may be even faster with a different arc motion, and it's getting out of this system. So now, then we get to where we get a satellite, it's theoretically 25,000 miles an hour, or whatever that is, and that stays in orbit. Now, we're seeking a lower orbit here with this track that we're showing, and that lower orbit strikes the surface of the Earth, so it kind of stays with the Earth and bonds with it, and so that ends that little investigation. Now, if you were to go through the center of the Earth, or through the Earth, that basically all these motions then would be seeking not the center point, but a lower orbit. Makes it for an interesting type of thing. So now we have, say, the Earth spinning, and we have, let's say, a solar arc, and we have a galactic arc, and I think we have a cosmic arc, and so forth and so on. And then we have like 2 points, 1 point here, 1 point there, different radii. That contributes to spin also. You'd have a difference in, since this is the Earth is somewhat solid, although we're worried about it, we have a lot of people making us start to worry about how solid the firmament is. Right now, we get translations of orbits. And basically, that's when the spin plane doesn't rotate. We don't bend it. So that's moving in all different positions. And you could look at it in one sense that if you have, say, a focal point here, again, you have those 2 points that are at different radii, so one side's going to go faster or further, or this side will go further than the far side since they're going the same rotational speed. And I'll ignore that C stuff. That gets into a little more of a conversation. But basically, translation of orbits, and that you get segmenting in the various arc motions that also contributes and may even be contributing to the spin of the Earth. But we have another proposal for that. Right now, when we get into bending the spin plane, this, of course, is gyroscopics. And so we have a wheel, a spinning wheel. Then we bend that. And so now our wheel gets to start to incrementally move into that position. Now we say we have a focal point. And I think you can get the geometry. You can question me on the geometry if you want. But let's say it's at least the initiation of every increment of motion. You're now moving this point closer to the focal point. These are moving further apart. So therefore, you're going to have more distance on the closer around the circumference is the smaller on the cone. Bigger on the cone, you go not as far. So that means you really, if you have the depiction of the spinning wheel, the solid line versus the dotted dash line, it shows, well, that should look more oval, but I failed on that. Anyhow, you get a displacement because of those two motions, this motion being more than this motion. And so to me, that's one geometric way of explaining precession. Now we get to the powered precession where we're either going to go into spirals or oscillations. So basically you're going to go into spiral if you keep your focal point like right there. That will have this wheel and you power that precession. So now you're going to go into a spiral. Then there's a lot to be expanding or converging, diverging, or converging spirals. Some say organic, non-organic, and negative entropy, positive entropy, and so I won't get involved in all that. But then you have a different focal point, and that causes oscillations. So we will get into them if I don't use up my time here. Now this one is, let's say McCabe and a lot of other people, but let's say Tesla said that there are some encodements or encryptions, I'm not sure I'm using his words, but anyhow, that are embodied into wave motion or spiral motion. And also there are encryptions or changes in the character of these spirals. And again, carrying these codes through. So now we carry these codes to a receiver converter, which would be hypothalamus, us, or maybe who knows what else, photosynthesis, anything you want to come up with in physics. And I just drew lines here. I don't even know what that's supposed to represent. Sorry, I can't figure it out. But somehow there's like I think it was Claude Swanson had spirals, and one spiral would be more of a spring opening, and another one. And when they meshed, then you would have a difference, and one would affect the other, so it's a collision. So the word collision is what I try to use in this. So anyhow, you're going to get these collisions that will take information, codes, personality, and then I somehow threw the word disease in one of my papers I delivered to in Russia. And so this was way out stuff. And I don't want to say I prided myself, but I tried to stick with just being a dumb mechanic and just talk about the things that we built, not this kind of thought process. So this could get any kind of criticism or construction that it might be needed. Now, possibilities and explanations. I just mentioned encoded ether torsions. That's really what I was talking about in that number 5. Then we have, of course, the atomic electron spin. Now, how does an electron know how to spin? Is it I have one little aspect of that I can't go into now too much, but where time, whoever, aliens, God, whoever you want to think, started a chunk of time, static time, and moved it into dynamic time, so static to dynamic. So in a way in, let's say this was condensing down into an electron. It became a hydrogen atom, and some people call that the Big Bang. And all the encoding and encryptions, and whoever started all this stuff or planned, or if you do or don't believe about that kind of thing. But anyhow, they got this whole deal going and said, now you know how to build a universe. Because everything was in those first hydrogen atoms. So helium, right on, thanks. I'm not going to get to my... All right, so now we get into planetary flat spin planes, solar and galactic arc travels, and all these are basically inherently gyroscopic. Now, if we take some application thoughts, some may be dysfunctional on my part, but whether you have so-called Coriolis, but you have the spin of the Earth, you have different radius of the Earth, you have the Earth traveling around the Sun, and basically you talk about pressure difference. Well, where are you going to get the pressure? I mean, it has to come from somewhere. So it's more gyroscopic that you would have an oscillation, but this would be one of the oscillations that go all. So weather is really a combination of those various motions, and it makes air go up into a spiral. And then we get in DNA. I just mentioned DNA just sort of offhandedly there before, but we think that there's a possibility of re-encrypting DNA to cure diseases. And I think I'm not the only one in that, but I wrote that, and of course Tesla said it, and then a guy named Royal Rife really went into this, big time. So, all right, so we have quantum mechanics, and we have Planck station, we have vortex power, and encryption codes, which I pretty much covered. And now we get into some devices. This is rapid linear motion, and this is pending in NASA's Inspired Game-Changing Technologies. And basically, we have a spin plane bending arm here. Then we have a precessional arm, and then we have linear motion along this path right here. Now, when I first built this thing, I didn't have this intervening, which I call precession, because I thought this motion, who cares whether it's in a straight line or not? Well, precessions must go in a curved line. Okay, so we got through, and this now it would allow tremendous rapid speed. I mean, this device, when it slides, itself across this shaft, a linear bearing. The speed is unbelievable. So NASA may look at that for propulsion. Now we all have here a bunch of gyro horizons from the airplanes, and basically this demonstrates two things, that this, without touching it, develops a frequency to motorize all these gyros. These are gyros, 4 gyros. Now there's a handle back here. We turn that handle, and these are all at random positions. They line up. Now during that line-up period, you feel the resistance. That resistance, I think, is the first mechanical demonstration of inertia. All right, so I'm out of time, and this thing's given up on me here. Okay, so now I want to get to the last one that I had here. I'll jump right to that, which is this device here. And we're in a process right now of building a device that converts 1 inch-pound of input with this little motor that will convert to 1,200 inch-pounds of work. This takes 1,200, 48 pounds times 25 inches, and that takes 1,200 inch-pounds. But 1 inch-pound from that motor, that's all that can put out, is doing this. It just barely can get that thing spinning. Now, I demonstrated in a video, which I can't show now, but that will just fall like Eric Lythway's bicycle wheel or whatever he used. But then when you get it spinning, it will just spin around, and we can use this torque to make output devices that can be used commercially, we think. All right, this device is a wagon, a small wagon, and it will power itself. We have a wheel in the very back end, and that goes through 180 degrees, and then the vehicle moves in that direction, and then the other second half, the 180 degree rotation of 360 degrees, it waves that way. So the thing continues to wave back and forth, and so that is vehicle motion. This one we have is what we call pulsed anti-gravity. We have a wheel, have one pivot of 3 arcs. Second arc is this one, which rotates this way, and then we have a pivoting of the whole assembly. Now we have a little indicator here that indicates that that is pulsing either up or down. And it takes quite a bit of a nice little sequencing of doing all this to get this to do this pulsing. But if we get a pulse where this moves up a little more than it moves down, then we have what we could think we can call anti-gravity. Then we have this device here that we call, as you see, oscillating crank power. So basically what we have is a little line up here, which is a compressor, and that little green thing is a balloon. And this, I was teaching in school, and so they decided to build this. So this is the world's first, we think, gyro-powered balloon inflating machine. So we have a flywheel, we have a crank, and then we have an assembly of gyros and powered precession. And the powered precession happens by having a little gear motor here, and then we have a motor that spins these 2 wheels, and then the little gear motor turns this around, and that ends up transferring oscillating motion along an arm, which is right in here. And we show a close-up view here of the 2 wheels, again, like we were saying, and that ends up doing the work of transferring a arc motion. And I seem to have lost the video in here, so we'll let that go. It ends up going through a crank and then operating the connecting rod to a compressor. Now this one we have where we have again a video of this where this would swing on a pivoting arm, a pendulum arm. These are 2 World War II fighter plane gyro horizons, and they spin and they oscillate, and the period of the pendulum allows this to become a motor. Could be that this is the way the planets actually work. So we have an air supply driving these two gyros, one at each end, and then that rotating assembly, as the pivoting motion occurs and the period occurs, normally it would oscillate, this would just oscillate back and forth. But it will become a motor once it's tuned to the period of the pendulum. And this shows the actual motion where it is actually in a period of rotating the motion, and that's a little motor that we actually use to operate another aspect of this, which we're not going to show in this presentation. And this one we did show that we had a 1.2 inch-pounds in on this little motor and 1,200 inch-pounds out, because this weighed 48 pounds at 25 inches, and we got ourselves quite a multiplication of torque, 1,000 to 1. And I know this is a very audacious statement, but that's the way it seems to work. And we think we can do a lot with this. We can get into a commercial thing, but we had covered this in the question and answer period before. Now, we get into a more exotic. This is Tesla's pyramid. And we have 4 gyros, and we have a elevating table here. A crank turns that up and down. Then we have a receiver gyro at the center of a pyramid structure, and that is about 50. Tesla indicated that 51.5 degrees is the point where this will tune itself and start spinning. And basically, you start any one of these gyros, and that'll start the other 3, and then they together, once you tune this location to this exact precise angle, that this gyro will start spinning and generate a fair amount of power. Of course, it depends on the mass of the wheel and so forth and so on. So basically, Tesla indicated in his notes that there was a year of his experimenting, and we got this only for a little period of time, to try this for only a little period of time here, and we didn't get it to work. Now, it was supposed to be a purplish aura that happens first, and then this becomes a power. And Tesla seemed to explain this, that there's a new kind of, or a power that we haven't seen, or a type of energy that we haven't seen. And it is something that is very special from the ether, in his view. So we're, as we say here, we're hoping that some university will begin a project, and I know it needs to be funding. Maybe we can find a way to fund it, to get into the investigation, a full-fledged investigation of gyroscopic physics. And we've certainly seen that we have enough in this phenomena to go beyond the merely toy and stability usage. And thank you very much. That concludes our talk on gyroscopes. Appreciate being here.
Thank you very much. So we have questions now.
Fran, you mentioned Royal Rife. I wonder if you could comment on elaborate on what you said he believed about or elaborate on your citation.
All right, he invented the electron microscope. When he was adjusting the power of the electron microscope, he was the first guy with that microscope could look at DNA cell. So he saw it change. He saw the shape or the pathway of the spiral change. So then after 10 years or 15 years or whatever, he somehow connected that to diseases, and he labeled diseases, and he ended up curing cancer by putting oscillation frequencies just to the body. And he did this in the 30s. The AMA crushed this poor guy, and he ended up dead, unfortunately.
Just to address the slide that's currently up on the screen, you seem to be describing it as what's known as an over-unity device. You say you're getting a lot more work out of it than the little motor is putting into it, and therefore I have to ask what I still think should be called the Hal Puthoff 1-watt challenge. Is there some reason why you can't harness the power that it's putting out and tap off a little bit of it to power the input motor and thus demonstrate that it really is producing more power?
As usual, you're very perspicacious, yes. Yes, I think you can tap off a little bit of power and use it, but you can drop that motor out of it, and it'll keep doing the work. Now, you have a bleed off because of aerodynamic spin or drag and the bearing friction, which are almost negligible, not quite. But if you get a really well-tuned gyroscope, it'll go for a long time before succumbing to that.
I'd like to suggest that it would be good to actually do that test and beyond simply saying that, yes, it should be doable.
We got it. Do I still have a minute or two? Somewhere here, if I can find it. Well, I should show you that over this. Yeah, here. Okay, here we have a video that I can play, I think. Oh, it's on the TV. Right there, I'm just showing that that it falls. Okay, big deal. Okay, so let's get to where it's actually doing something. So now we get that spinning. An estimate of the RPM, you can almost estimate it yourself. It's not real fast. It's maybe 600, 700.
So try not to let it bounce too much.
Thank you, Ernie. So there's a demonstration.
Yeah, that's a good one.
Now, if you, like I have a vice grip hanging on that shaft, that vertical shaft, and then that little motor. Okay, now when you grab the vice grip and push that so you power the precession, that will spiral up. Now, it's handling 1,200 pounds. The only input to this is whatever the world cosmos has to offer, according to Tesla, and he knows only, maybe he's the only one that knows, is that little motor that is rated at 2.5 inch-pounds, and I put 6 volts on the motor, and it still does the job, so it's around 1 inch-pound, and it's getting 1,200 inch-pounds. So whatever you want to think about that, I defer to your thought processes.
Thank you very much.
Okay. All right, thanks.